This is Euclid Book 10, proposition number 37. And here is the diagram. You have two lines here, AB and BC, and when you add them together, they're going to make the line AC. When you're doing this proof with me, I want you to actually draw out what I tell you to draw out. It will make it a lot easier for you to visualize the stuff once you do. Alright, we're going to have you draw the square AB, we're going to have you draw the square BC. We're actually going to have you draw a rectangle which two sides are going to be AB and two sides are going to be BC. And then you're going to draw a square called AC. Now you say, well, how do we draw all this? Well, when you say square AB, you're talking about taking this line, making a square out of it, and each side of the square, each side of it is going to be the length of AB. Same thing here. You're going to make a square, and each side of the square is going to be BC. When you talk about this rectangle, two sides are going to be AB, and two sides are going to be BC. In other words, the length's going to be AB, and the width's going to be BC. Okay, so, and the same thing with AC. When you draw it out, you're going to have four sides of a square. Each side is going to be the length of AC. That's what you're talking about. Okay, now, if two medial straight lines commensurable in square only and containing a rational rectangle be added together, the whole is irrational, and let it be called a first bimedial straight line. So now we're going to define a first bimedial straight line. For let two medial straight lines AB and BC commensurable in square only and containing a rational rectangle be added together, I say that the whole AC is irrational. For since AB is incommensurable with Euclid BC, okay, so now we're saying that these two lines right here, this line here and this line here, they're incommensurable in length, but they are commensurable in square. Therefore, the squares on AB and BC are also incommensurable with twice the rectangle AB and BC, and this is by Euclid Book 10, proposition number 36. So if we add these two together, and I'll show you this, if you add these two together, that whole area is going to be incommensurable with twice the area of this rectangle. Okay? And componendo, the squares on AB and BC, together with twice the rectangle AB and BC. So in other words, you're going to add these two together. Now you're going to add twice the area of this. You're going to add all this together. And before you add it all together, you have to realize that twice the area of this is actually this. Okay? Twice the area of this is actually this. So twice the area of AB and BC is actually the square of AC. Okay? And this is by Euclid Book 2, proposition number 4. Is incommensurable with the rectangle AB and BC. So if you add all of these areas up together, this one, this one, this one, you add them all together, that area combined is incommensurable with the area of the rectangle ABBC. Okay. And that's by Euclid Book 10, proposition number 16. But the rectangle ABBC is rational, for by hypothesis AB and BC are straight lines containing a rational rectangle. Therefore the square on AC is irrational, therefore AC is irrational. So if the square on AC is irrational, then AC, the line, is irrational. And that's by Euclid Book 10, definition number 4. And let it be called a first bimedial straight line. So, we're now going to call the length of AC a first bimedial straight line. And that's the definition of it. I will tell you more in a future video. Stay tuned.